December 1944. In the freezing mud of the Ardennes, an American armored recovery vehicle hauls a heavily damaged M4 Sherman out of a ditch, its crew preparing to fight again within days. Just miles away, a virtually untouched German Tiger II sits abandoned in the snow, permanently lost over a single stripped transmission gear. By every traditional metric of armor and firepower, German heavy tanks should have dominated this battlefield. Yet it was the battered, mass-produced American tank that consistently returned to the fight. How did a supposedly inferior machine turn an uneven match into a relentless mechanical resurrection? For decades, popular history and post-war memoirs have framed this exact scenario through a distorted lens. The M4 Sherman is routinely dismissed as a disposable death trap, while heavy German armor is elevated to the status of an unmatched engineering marvel. But this romanticized view relies on a fundamental misunderstanding of mechanized warfare. A tank's true value is never measured in a sterile, one-on-one duel on an open proving ground. It is measured in operational readiness, resilient supply chains, and the mechanical stamina to absorb massive daily friction over months of continuous combat. We are going to explore the hidden industrialized war of World War II, a conflict decided not strictly by armor thickness or muzzle velocity, but by maintenance schedules, standardized replacement parts, and dedicated armored recovery units. The clash between the enduring legend of German technological supremacy and the cold, unyielding logistical truth reveals exactly how the Allied war machine systematically dismantled its enemy. But to understand how the Allies built a system capable of overwhelming technically superior Axis armor, we have to look back at the brutal constraints American planners faced long before a single tank ever reached European soil. In the spring of 1942, the United States Army Ordnance Department stared down a geographic reality that no amount of engineering genius could simply wish away. The American military was thousands of miles from any active combat zone. Every single tank, bullet, and spare part destined for the European theater had to survive a transatlantic crossing. They had to be packed tightly into the cramped cargo holds of Liberty ships and unloaded by conventional port-side cranes in Britain or North Africa. This fundamental logistical choke point dictated the rigid physical laws of American tank design. The maximum lifting capacity of standard commercial dockside cranes at the time was roughly 30 to 35 tons. Furthermore, the width of the vehicle was strictly governed by the dimensions of flatbed rail cars and the cargo hatches of maritime transport vessels. The United States could not build a 60-ton armored Leviathan even if it wanted to. There was simply no practical way to deliver it in mass quantities to the battlefield. The physical envelope of the M4 Sherman was essentially drawn by the infrastructure of global commercial shipping. But geography was only half of the equation. The other half was the human element. Before Pearl Harbor, the United States Army was remarkably small, its armored forces practically non-existent. To fight a global war, the War Department had to rapidly expand, drafting millions of young men from Midwestern farms, southern textile mills, and urban garages. The men tasked with operating and maintaining the armored force were not master engineers or specialized heavy industry technicians. They were rapidly trained, everyday citizens who needed a machine that made intuitive mechanical sense. The mandate from military planners was unyielding. The new medium tank had to be highly reliable, easily manufactured, and, above all, modular. It required standardized, universally interchangeable parts. Chrysler's Detroit Arsenal tank plant and other automotive giants applied the ruthless efficiency of the modern assembly line directly to lethal mechanized warfare. If an American armored division operating in a muddy field had a Sherman with a blown transmission, a maintenance battalion comprised of 19-year-old mechanics had to be able to unbolt the damaged differential from the front hull, drop in a fresh unit, and have the crew back in action by morning. The engine compartment had to be easily accessible. The tracks had to be simple to replace, with basic wrenches and crowbars. The Sherman was designed not just as a fighting vehicle, but as a resilient, easily replenishable node in a massive, globe-spanning supply chain. The American military doctrine accepted a grim truth. Tanks would inevitably be destroyed or break down. The system was designed around rapidly repairing them, rather than trying to build an indestructible machine. Meanwhile, on the continent, the German high command was absorbing a deeply traumatic set of lessons. Stunned by their encounter with the heavily sloped armor of Soviet T-34 and KV-1 tanks during the opening months of Operation Barbarossa, German military planners panicked. The directive from the highest levels of the Reich shifted violently away from the operational mobility that had defined the early Blitzkrieg and moved strictly toward absolute tactical dominance. German industrial giants like Henschel, Porsche, and Krupp were ordered to design heavily armored, highly complex beasts. The new philosophy was simple: build an impenetrable fortress capable of dominating any Allied vehicle from far beyond return fire range. This singular focus on battlefield lethality birthed the heavy Tiger I, and eventually the Panther and the massive Tiger II. As individual pieces of engineering, they were terrifyingly capable. But this pursuit of mechanical perfection came with a staggering operational cost. German industry often retained a craftsman-like, hand-built mentality. Tanks were frequently modified on the assembly line, meaning a suspension part for a Panther built in March might require custom machining in the field to fit a Panther built in July. Their intricate, overlapping, interleaved road wheels provided a remarkably smooth ride and excellent weight distribution for the heavy hulls. Yet, if an inner wheel was damaged by a landmine, or simply froze solid with Russian mud overnight, crews had to jack up the tank and manually remove up to a half-dozen outer wheels just to reach the broken one, an exhausting, hours-long task under combat conditions. Furthermore, to transport a Tiger tank by standard European rail, crews actually had to remove the outer row of road wheels entirely and swap the wide combat tracks for narrow transport tracks, just so the vehicle wouldn't smash into passing trains or tunnel walls. Maintenance on their advanced Maybach engines was equally complex, often demanding specialized lifting gantries and highly trained mechanical specialists that the German army was rapidly running out of. By the end of 1942, the strategic divergence was fully locked in. Two entirely different philosophies of war were set on an unavoidable collision course. The United States optimized for global logistical volume, prioritizing mechanical reliability, perfectly standardized parts, and the ability to rapidly repair and regenerate combat power on an industrial scale. Germany, increasingly forced onto the strategic defensive, optimized for localized engineering perfection, betting their survival on the hope that a smaller number of invincible tanks could bleed the sprawling Allied armies dry in single-engagement duels. The drawing boards, the shipping docks, and the competing industrial mandates had established the unbreakable rules of engagement. The blueprints were approved, the factories were churning out steel, and the sheer momentum of these vastly different war machines was building toward a climax. But the true test of these competing philosophies, global volume versus localized perfection, would not be decided by theoretical math, nor on the pristine testing grounds of Aberdeen or Kummersdorf. The real reckoning was waiting in the claustrophobic, blood-soaked hedgerows of Normandy. When the Allied armored divisions finally pushed into the Norman bocage in June 1944, the theoretical debates ended in brutal, immediate reality. The geography heavily favored the German defenders. Ancient, sunken dirt lanes and dense hedgerows forced the advancing American Shermans into fatal, predictable bottlenecks. Waiting for them in the shadows were camouflaged German Panthers and perfectly concealed PAK-40 anti-tank guns. In these claustrophobic, short-range engagements, the German philosophy of thick frontal armor and high-velocity guns paid devastating dividends. American armored columns drove directly into meticulously sighted kill zones, and their initial losses were staggering. Throughout July, German after-action reports flowing back to division headquarters painted a picture of absolute tactical triumph. Veteran armored formations were logging massive numbers of destroyed American tanks. By every traditional metric of armored warfare, the German defenders believed they were decisively winning the battle of attrition. They were successfully trading space for steel, confident that the sheer lethality of their heavy tanks was bleeding the American armored forces to the point of collapse. For the high-ranking officers tallying these reports, their mandate of technological supremacy felt completely vindicated. But within a matter of weeks, German forward observers and intelligence officers began documenting a mathematical impossibility. A German Panzer unit would engage and decimate an American armored formation on a Tuesday, visually verifying dozens of disabled, abandoned, or heavily damaged Shermans. By all established military logic, that American unit should have been rendered combat ineffective for a month, requiring a long withdrawal to the rear for a complete reconstitution. Yet, at dawn on Thursday, That exact same American formation was cresting the next ridge, probing the lines and attacking at near full operational strength. The subsequent reports deeply unsettled the German commanders. The arithmetic of the battlefield was breaking down. They were systematically destroying the American armor, exactly as their heavy machines were designed to do, but the American front line never thinned out. The German officers rationalized this anomaly by assuming they were facing an infinite, bottomless reserve of factory-new tanks rolling straight off the invasion beaches to simply replace the fallen. They were wrong. The Americans were not just pouring in fresh machines, they were resurrecting the casualties. The German command, meticulously counting shattered steel hulls left in the mud, was entirely blind to the massive, industrialized recovery apparatus operating in the pitch black just a few miles behind the American lines. As dusk settled over the Norman bocage and the crack of high-velocity tank guns faded into sporadic rifle fire, the dynamic of the battlefield fundamentally shifted. When the fighting paused, and the German heavy armor pulled back into camouflaged perimeters to conserve their precious fuel, the American ordnance battalions went to work. This was the unseen theater of the war, a choreographed logistical ballet performed under the cover of darkness and the constant threat of zeroed-in mortar barrages. Heavy wreckers, primarily the M32 tank recovery vehicle, a modified Sherman chassis stripped of its main gun and fitted with a massive A-frame winch and a 60,000-pound pulling capacity, crept out of the tree lines and into the smoldering no-man's land. Their crews were not standard infantrymen. They were mechanics, welders, and heavy equipment operators, given an almost impossible mandate: drive into the kill zones, locate the dead machines, and drag them back to the rear before the sun came up. When an M32 hauled a disabled Sherman back to a concealed field depot, the machine did not sit idle, waiting for the war to end. It was immediately absorbed into a ruthless system of mechanical triage designed with the exact same assembly line precision that had built the tank in the first place. Army doctrine dictated that combat repairs be categorized by time and proximity to the front. If a malfunction could be fixed in under 24 hours, the vehicle stayed immediately behind the line with the battalion maintenance company. If the tank had suffered severe battle damage, perhaps its tracks were blown off by a teller mine, or its turret ring jammed by a 75mm shell, it was pushed slightly further back to an ordnance medium maintenance company, operating with a target turnaround time of 3 days or less. The sheer industrialized speed of this operation was baffling. A Sherman that took a catastrophic hit on a Tuesday afternoon would be dragged back, stripped of its shattered components, and fitted with fresh steel overnight. The welding torches sparked until dawn, cutting away jagged armor and fusing new plates over penetration holes. By Thursday morning, that same Sherman was gassed up, loaded with ammunition, and rolling right back up the exact same dirt lane. To the German gunner peering through his Zeiss optics, counting his kills, it looked as though the Americans possessed an infinite swarm of factory-new vehicles rolling straight off the beaches. In reality, he was frequently shooting at the exact same hull he had disabled 48 hours prior. This blistering pace of battlefield resurrection was deeply hardwired into the fundamental blueprint of the tank itself. The M4 Sherman was a masterpiece of modular pragmatism. Consider the heart of any tank's tactical mobility, the transmission and the final drive. In the brutal, stop-and-go environment of armored combat, transmissions inevitably shatter under the immense torque. When a Sherman suffered a catastrophic internal transmission failure, or an anti-tank shell cracked the front casing, it did not require a trip back to a heavy factory in England. The entire front armor casting of the Sherman, the heavy steel nose housing the differential and final drive gears, was deliberately designed to be unbolted from the main hull. A trained field crew, operating in a waterlogged French orchard with nothing more than a chain hoist and standard wrenches, could shear off the heavy retaining bolts. They could pull the entire broken, multi-ton transmission assembly out of the tank as a single unit, drop it in the mud, and slide a factory-fresh replacement straight into the cavity. Because American wartime manufacturing relied on absolute adherence to standardized tolerances, a replacement transmission built by Chrysler in Detroit perfectly matched a steel hull welded by Fisher Body in Michigan. It required absolutely no custom machining in the field. There was no filing down edges, no heating metal to force a fit, and no desperate hammering to make the critical gears align. The parts simply slotted together. This plug-and-play architecture extended throughout the entire mechanical anatomy of the machine. A damaged radial engine could be hoisted out of the rear bay and completely replaced in a matter of hours. Bogie wheels, track links, electrical harnesses, and even entire turret assemblies were universally interchangeable across thousands of active vehicles. The American military apparatus had effectively brought the efficiency of the Detroit assembly line directly to the front lines, transforming a violently destroyed tank from a permanent combat casualty into a temporary administrative inconvenience. This sprawling ecosystem of rapid, standardized repair turned the Sherman into a mechanical zombie. It simply refused to stay dead. Directly across the front lines, the situation within the German armored battalions was rapidly descending into an agonizing logistical nightmare. The German Panther tank, widely considered one of the most lethal and technologically advanced medium tanks of the war, harbored a fatal architectural flaw hidden beneath its sloped armor. Like the Sherman, the Panther utilized a front-mounted transmission. But completely unlike the pragmatic American engineers, the German designers, obsessed with absolute ballistic integrity, sealed the Panther's transmission behind a solid, steeply angled steel glacis plate. There was no unbolting the front nose to quickly access the internal machinery. When a Panther's highly complex transmission inevitably snapped, a frequent occurrence given the vehicle's excessive 45-ton weight, the repair process was excruciating. To extract a shattered transmission, German mechanics could not simply pull it out through the front hull. They had to physically access it from above, hauling it up through the roof of the driver's compartment. But sitting directly over that small extraction hatch was the tank's massive main gun and the heavily armored turret. Therefore, just to fix a broken internal gear, the entire turret assembly, weighing roughly 8 tons, had to be completely lifted off the hull and suspended in the air. This delicate operation required highly specialized heavy lifting equipment, typically the massive Strabo-Fries gantry crane, which had to be constructed over the tank like a bridge, or a synchronized team of multiple 18-ton FAMO half-tracks acting in unison. Setting up this massive lifting apparatus required pristine conditions, flat, highly stable ground, a secure rear area far removed from enemy artillery, and a team of specialized heavy maintenance engineers. In a fully equipped workshop deep inside Germany, this was a manageable procedure. But in a cratered, muddy field in Normandy, with Allied artillery spotters probing the lines, it was a logistical impossibility. A transmission swap that took an American ordnance crew a handful of hours using standard hand tools took a German heavy maintenance crew several days of exhausting, highly vulnerable labor, assuming the repair could even be attempted. As the grinding summer of 1944 bled into autumn, and the Allied breakout sent the German army into a chaotic retreat across France, time and space became the ultimate executioners of the Panzer divisions. In a static defensive line, a broken-down heavy tank could sometimes be carefully recovered, towed back to a secure railhead under the cover of darkness, and shipped back to a factory. But in a rapidly collapsing mobile war, the German armored forces simply ran out of time. Furthermore, they were operating under a sky they no longer controlled. The Allies had achieved absolute, crushing air superiority over Western Europe. Swarms of American P-47 Thunderbolts and British Hawker Typhoons, armed with heavy machine guns and high-explosive rockets, prowled the skies, turning the French road network into a graveyard for anything moving in daylight. German armored recovery operations, already severely hindered by a critical shortage of the heavy FAMO half-tracks required to pull their massive vehicles, ground to a halt. To drag a disabled nearly 70-ton Tiger II, or a broken Panther, out of a ditch required linking 3 of these heavy half-tracks together in a long, slow-moving train. This agonizingly slow procession was an immediate magnet for Allied fighter bombers. Consequently, German tank crews and recovery units were forced to operate almost exclusively at night, under strict blackout conditions, on narrow dirt roads already congested with retreating infantry and horse-drawn artillery. The mechanical friction inherent in the heavy German beasts began to compound exponentially with every mile they retreated. A Tiger tank required meticulous, constant maintenance just to keep its intricate, overlapping road wheels turning and its massive Maybach engine running without overheating. But the vital spare parts required to keep them moving were frequently stranded on bombed-out supply trains hundreds of miles to the east. high-octane fuel, required in massive quantities just to haul these steel fortresses down the road, was running disastrously low due to the relentless Allied strategic bombing of synthetic oil plants. The finely tuned German war machines, starved of routine maintenance, replacement parts, and petroleum, began to systematically cannibalize themselves on the retreat. By late 1944, as the weather turned freezing and the Allied armies pushed toward the borders of the Reich, the operational reports flowing from the front lines into the German high command were no longer boasting of favorable tactical kill ratios. Instead, they were documenting a grim, undeniable structural collapse. The tone of the enemy perspective shifted violently from arrogant technological confidence to deep administrative despair. Division commanders, veterans of the sweeping armored victories of the early war, were forced to formalize a devastating truth in their war diaries. They were now losing significantly more of their irreplaceable heavy tanks to their own retreating hands than to Allied armor-piercing shells. The late war records of the elite Panzer divisions are filled with identical, agonizing entries that highlight this logistical death spiral. A Panther blows a final drive seal while trying to reverse up a muddy incline. A Tiger II strips a critical steering gear while attempting to pivot in a narrow, rubble-strewn village street. The mechanical failure is minor, but the consequences are absolute. Without the heavy gantry cranes to lift the turrets, without the specialized half-tracks to tow the massive dead weight, and with fast-moving American armored columns closing in from the flanks, the stranded German crews faced only one grim option. They had to systematically destroy their own engineering marvels. Tank commanders ordered their men to pack thermite grenades into the pristine breeches of their vaunted 88mm guns. They poured their remaining rations of gasoline over the meticulously crafted engines, slashed the internal wiring harnesses, and threw a match. The very complexity, thickness, and immense weight that made German heavy tanks so utterly terrifying in a static firefight made them incredibly fragile in a dynamic strategic retreat. A minor mechanical failure, a shattered gear, or a blown gasket that an American ordnance crew would have swapped out before breakfast became an immediate, unappealable death sentence for a German heavy tank. The landscape of Western Europe quickly became littered with the charred, blown-out husks of Tigers and Panthers, abandoned by their desperate crews and detonated from the inside out to prevent capture. The vaunted German logistical system had not just bent under the immense pressure of the Allied advance, it had shattered entirely, unable to support the very machines it had built to win the war. The American strategy of massive logistical volume, strict standardization, and rapid mechanical regeneration had comprehensively overwhelmed the German reliance on heavy, localized, and unmaintainable perfection. Keeping these tens of thousands of metal holes running across a shattered continent was undoubtedly an absolute masterclass in industrial mobilization and an unprecedented logistical triumph. The massive American system worked exactly as the planners in Washington had originally envisioned, grinding the enemy down through a relentless, inescapable tide of mechanical resurrection. But keeping the steel moving is only half the equation, because metal does not win wars on its own. A resurrected, freshly welded tank is utterly useless without a human crew to man it. And the heavily obscured, hidden factor in this logistical victory, the true, agonizing cost of sending the exact same machines back into the fire again and again, contradicts decades of sanitized popular folklore about how this war was actually fought. The enduring post-war myth of the M4 Sherman is that it was a disposable metal coffin, a notorious death trap where American tank crews were systematically annihilated by superior German firepower. But the forensic evidence collected by the United States Army Ballistic Research Laboratory tells a radically different, almost counterintuitive story. As military investigators meticulously examined knocked-out Shermans across the European theater, tracing armor-piercing shell trajectories and analyzing internal burn patterns, they uncovered a startling statistical reality. On average, when a Sherman was cleanly penetrated and completely destroyed by enemy fire, only one crew member died. This incredibly high survival rate was not a product of battlefield luck. It was the result of deliberate, pragmatic engineering. By wartime standards, the Sherman featured a relatively spacious interior, granting men the physical room to react and escape. American designers implemented spring-loaded quick-release hatches that popped open instantly under pressure. By 1944, They had also introduced wet stowage, encasing the main gun ammunition in water-jacketed bins to significantly delay the catastrophic internal fires that trapped crews inside. Consequently, when a high-velocity German 88mm shell slammed into a Sherman, the machine itself was often a total write-off, but 4 out of the 5 men usually bailed out alive. They scrambled into the mud, walked back to a rear echelon depot, and were simply handed a freshly repaired replacement tank the very next morning. This cycle exacted a massive psychological toll on the men, forcing them to survive the violent destruction of their vehicle only to be ordered right back into the line of fire hours later. But on a strategic level, it meant the American military was not just recycling steel, it was recycling invaluable combat experience. While the German army was hemorrhaging highly trained, irreplaceable veterans who were forced to abandon and scuttle their broken-down heavy tanks, the Americans were systematically preserving their own veterans. This institutional ability to sustain human capital forged a hardened, profoundly experienced armored force. And that collective resilience was about to face its absolute breaking point in the freezing, fog-choked pine forests of the Ardennes. On December 16, 1944, out of the freezing fog of the Ardennes, the German High Command launched their final, desperate gamble in the West. Operation Wacht am Rhein was spearheaded by the 6th Panzer Army, a massive armored fist equipped with the heaviest, most lethal machines Germany could muster, including concentrated battalions of the fearsome, nearly 70-ton Tiger II. The entire offensive was predicated on the brute force shock of these heavy tanks punching rapidly through the thinly defended American lines, shielded from Allied fighter bombers by a dense, grounding winter storm. Initially, the shock was absolute. The sheer weight and firepower of the German vanguard shattered the frontline American infantry divisions. But as the Panzers plunged deeper into the narrow, winding forest roads of Belgium, the unforgiving laws of logistics began to catch up with them. The Ardennes was a maze of icy ravines, single-lane dirt tracks, and structurally fragile stone bridges. It was the absolute worst possible environment for heavy, over-engineered armor. When the weather finally cleared in late December, the German offensive did not just stall, it physically collapsed under its own immense weight. The logistical nightmare the German commanders feared had materialized on a catastrophic scale. A single King Tiger sliding off an icy forest road and throwing a wide combat track would instantly paralyze an entire armored column. With no specialized recovery vehicles capable of hauling a 70-ton behemoth out of a frozen ditch, the road remained permanently blocked, and as the columns idled in the freezing cold, unable to maneuver around their own stranded machines, their massive engines burned through the very last of their strictly rationed fuel reserves. On the other side of the line, the battered American armored divisions absorbed the initial terrifying blow and leaned directly into the industrialized system they had perfected over the summer. Surviving tank crews, hardened men who had already bailed out of destroyed Shermans in Normandy and Aachen, simply fell back, regrouped, and were handed operational machines. American ordnance battalions operated around the clock in sub-zero temperatures. Mechanics lay in the freezing snow, using blowtorches to thaw frozen track pins and installing factory-fresh engines shipped straight from Detroit, keeping the American armor relentlessly on the move. When the Allied counteroffensive finally struck, the tactical picture was completely unrecognizable. American Shermans, mechanically reliable and light enough to navigate the treacherous winter terrain, swept into the German flanks. They did not find an unstoppable, mechanized juggernaut waiting for them. Instead, they found a paralyzed vanguard. The elite German armored divisions were frozen in place, their impenetrable tanks abandoned in the snow or reduced to static steel pillboxes, defeated not just by American guns, but by the complete collapse of their own unmaintainable engineering. When we return to that freezing trench in the Ardennes, the image of the abandoned Tiger II and the patched-up Sherman takes on a completely different meaning. That pristine German Leviathan, sitting silently in the snow, was the ultimate expression of the Reich's philosophy of mechanized war. It was an artisanal, nearly impenetrable fortress designed to dominate any theoretical duel. But the moment a single bespoke transmission gear stripped and the specialized recovery vehicles failed to arrive, all that thick armor became instantly irrelevant. It was reduced to a 70-ton roadblock. Just down the road, the mud-caked Sherman being hauled out of the ditch represented the exact opposite. It was never designed to be invincible. It was designed to be inevitable. It was a standardized, modular component of a sprawling, unglamorous logistical machine built specifically to absorb massive battlefield friction. If a mechanical part shattered, it was unbolted and replaced overnight. If the hull was pierced, the pragmatic design allowed the crew to escape, survive, and return to the line in a newly repaired vehicle by morning. The tragic irony of the German armored campaign was that their relentless pursuit of engineering perfection led directly to their systemic operational collapse. They built machines too complex to maintain under fire, too heavy to tow, and too valuable to lose. The United States accepted the grim, attritional reality of modern industrial warfare. They built a system that simply refused to stop moving, keeping seasoned veterans in the turrets and freshly welded steel on the tracks. The decisive clash of armor in Western Europe was not ultimately decided by the theoretical perfection of a Munich drafting room. It was won in the freezing mud of forward repair depots and on the relentless, standardized assembly lines. Ultimately, the German High Command chased a fatal illusion of absolute invulnerability, pouring their dwindling industrial resources into mechanical masterpieces that were terrifying in an isolated duel, yet completely incapable of surviving the grinding friction of a continental conflict. The enduring myth of Axis technological supremacy was methodically buried under a mountain of perfectly standardized American spare parts. The legendary German heavy tanks were engineered to win individual battles, but the modest, easily repaired Sherman was engineered to win the war.